Hello students, welcome to lecture number 6 on the topic relations. Today we will discuss some practice questions. So this will be a question practice session. So this was your homework question. So let's solve this. Let A be a set which contains elements from 1 to 14. We define a relation on set A by R equals to the set of all those ordered pairs which satisfies 3x minus y equals to 0. Obviously x and y belongs to A. We need to find here the domain of R and range of R, right? Now see, in this ordered pair, x belongs to A and y belongs to A, and this condition must be satisfied by this ordered pair. So basically this condition means 3x equals to y or y equals to 3x. Now see, you put x equals to 1, then you get the condition is y equals to 3x. So in place of x put 1, so 3 into 1 is 3, that belongs to A. Put x equals to 2, then y is equals to 3 into 2 6, which also belongs to A. Put x equals to 3, then y equals to 9, which also belongs to A. Put x equals to 4, then y equals to 3 into 4, which is equal to 12, which belongs to A. But if you put x equals to 5, then y equals to 3 into 5, which is 15, and 15 does not belong to A, as A contains elements from 1 to 14. So this pair 5, 15 will not belong to R, as 15 doesn't belong to A, right? So we have our R as R equals to 1 3 2 6 3 9 4 12, right, from here. So the domain of R will be the set of first components 1 2 3 and 4, right? Domain is this. Similarly, the range of R is what? The set of all second components 3 6 9 and 12, right? And the codomain is set A itself. Suppose this is my set A from A. Now R is a relation from set A to itself. So your codomain is the second set, right? This is your codomain. As you can see here that range is a subset of codomain. I hope this question is clear to all of you. If you have any doubt in any of this question, you may comment in the comment box, right? So moving on to the next question. Find the inverse relation R inverse in each of the following cases. Given here R equals to this set, so this implies R inverse is what? Just interchange the position of the elements, means 1 2 will become 2 1, 1 3 will become 3 1, 2 3 will become 3 2, and 3 2 will become 2 3, and 5 6 will become 6 5, right? So if in this question you are asked what is the domain of R? So the domain of R is what? The set of all first components 1, 2, 3 and 5 will come in domain, and the range of R is what? The set of all second components 2, 3 and 6, right? See for R inverse you can also find the domain of R inverse, the set of all first components 2, 3 and 6, 2, 3 and 6, and you may also find the range of R inverse, which is the set of all second components 1, 2, 3 and 5, 1, 2, 3 and 5. You may see from here that the domain of R and the range of R inverse are equal, right? And the range of R and the domain of R inverse are equal as they contain 2, 3 and 6, right? These things we have discussed in our previous lectures. So this question is done. Question number 1 is done. For question number 2, now the R contains all those ordered pair of the form xy such that this condition is satisfied by those ordered pairs where xy belongs to N. We need to find R inverse in each case. Now we will solve this as well. See, this was the question. R contains all those ordered pair of the form xy where this condition is satisfied by the ordered pair where x and y belongs to N. So clearly R is a relation from N to N. Why? As xy belongs to N cross N, as x belongs to the set of natural number and y also belongs to the set of a natural number, so xy belongs to N cross N, and R contains all those xy, right, such that it satisfies a particular condition, means R is a subset of N cross N. Therefore by the definition of a relation, R is a relation from N to itself, or R is a relation from N to N, or you may say that R is a relation on the set of natural numbers, right? Now this condition must be satisfied by this ordered pair. Now see here, put a y equals to 1 in this condition, then x plus 2 into 1 equals to 8, means x plus 2 equals to 8, means x equals to 8 minus 2, which is 6. So we get the first pair as 6, 1, this. Okay. Next, put y equals to 2 here in this equation number 1. Then you get x plus 2 into y is 2 here is 8, means x plus 4 is 8, so x equals to 4. See, so x equal to 4. We get the second ordered pair as 4, 1. Similarly, put y equals to 3. You will get x plus 2 into 3 is 6 equals to 8. So x equals to 8 minus 6 is 2. You get the third ordered pair as 2, 3. Now put y equals to 4, right? So x equal to what? X equal to 8 minus 8. So x equals to 0, but 0 does not belong to the set of natural. So 0 comma 4, so 0 comma 4 will not belong to R, right? So we get R as 6 comma 1, 4 comma 1 and 2 comma 3. If we were asked to find the domain and range of R, so domain of R will be the set of all first components, so 6, 4 and 2, 6, 4 and 2, and the range of R is what? The range of R is set of all second components 1 and 3. Now we will find the R. R inverse is the, just interchange the elements. 6 comma 1 becomes 1 comma 6, 4 comma 1 becomes 1 comma 4, 2 comma 3 becomes 3 comma 2. Here the domain of R inverse, here the domain of R inverse is what? The set of all first components 1 and 3, 1 and 3, which you can clearly see that a range of R is equal to domain of R inverse. Similarly, if you find the range of R inverse, this will be equal to 6, 4 and 2, which is equals to domain of R. I hope this question is clear to all of you. Next, part C was R is a relation from this set to this set, defined by this equation, right? So let us suppose that this is my set A and this is my set B, right? Now R is a relation from set A to set B, where we have assumed that my set A is this and my set B is this, and it also satisfies this condition, right? So x will belong to A and y will belong to B. As R is a relation from A to B, this means that R is a subset of A cross B. Means if R contains the ordered pair of the form x comma y, then this x will belong to A and this y will belong to B, and this satisfies y equals to x minus 3 condition, right? Y equals to x minus 3 condition. So you may put x equals to 11 here. You will get y equals to x minus 3. So y equals to 11 minus 3 is 8. Now check whether this 8 belongs to the set B. So yes, 8 belongs to B. See here. But if you put x equals to 12, then y equals to 12 minus 3 is 9. Now 9 does not belong to this set B, right? Therefore this pair 12 comma 9 will not belong to R, right? Similarly, put x equals to 13, you will get y equals to 13 minus 3 equals to 10, which belongs to B. So this pair will belong to R. Similarly, this pair 11 comma 8 belongs to R. So let's see the mapping diagram over here. So 11 maps to 8, 12 maps to none, as 9 is not in set B, and 13 maps to 10. This is the arrow diagram for this question, right? So our R is this and our R inverse is this. Now if you were asked to find the domain and range from the arrow diagram, you may see that two elements have only mapped with two elements of set B. So since a domain is a subset of set A, therefore from the above figure, domain of R equals to 11 and 13. You may see it from here as well, from R as well. The set of first component is 11 and 13, so the domain of R is 11, 13, right? You can find out a domain by both these methods. Now if R is this, then R inverse can be easily obtained by interchanging the position of the elements. Means interchange the position of 11 and 8, you get 8, 11. Similarly interchange the position of 13 and 10, you get 10 and 13, right? I hope this question is clear to all of you. If you have any doubt, you can comment in the comment section, and you may send your doubt to me, right, on my email ID, which is given in the description box, right? Now next question is, let A contains two sets 1 and 2 and B contains 3, 4. We are required to find the total number of relations from set A to set B. Now see clearly, cardinality of A is what? Since A contains two elements, so cardinality of A is 2, and B contains also two elements, so cardinality of B is 2. We know that total number of relations from set A to B is equals to 2 to the power cardinality of A times cardinality of B, right? So here cardinality of A is 2, so 2, and cardinality of B is 2, right? This will be 2 to the power 4, which is equals to 16. Therefore total number of relations from set A to B is equals to 60. I hope this is clear to all of you. Next question. Determine the domain and range defined by R equals to the set of all those ordered pair of the form x comma x plus 5 such that x belongs to this set. We have seen R of this form, right? X comma y such that x belongs to this 0, 1, 2, 3 and 4 and 5. Now in place of y we have x plus 5, right? So let us construct this relation first so as to get the domain and range. Now see the solution. Now since x belongs to this set 0, 1, 2, 3, 4, 5, and the second component is x plus 5, so let x comma y belongs to R, right? Where y is the second component, means y equals to x plus 5 over here, right? Now put x equals to 0, then y equals to x plus 5, which is equal to 0 plus 5 is 5. So we get the first pair from here as 0, 5. Next, put x equals to 1, then y equals to x plus 5, which is equals to 1 plus 5 is 6. We get the second component from here as 1, 6. Similarly, put x equals to 2, then y equals to 2 plus 5 equals to 7. So we get the third component as 2, 7. Basically, we are constructing R. So we have got the first element as 0, 5, second element as 1, 6, third element as 2, 7. Similarly, put x equals to 3, then y equals to 3 plus 5 equals to 8. Then you get the fourth pair as 3, 8. Then put x equals to 4. X equals to 4. Then y equals to 4 plus 5, which is equals to 9. Then you get the fifth pair as 4, 9. Then you can put x equals to 5. Then y equals to 5 plus 5 is 10. So you get 5, 10. Can you put x equal to 6? My question to you is this. So the answer is no, as x lies between 0 to 5. So we cannot put x equals to 6, as x lies between 0 to 5, right? So we cannot put x equals to 6. I hope this is clear to all of you. So we have constructed R. Now we can easily find the domain and range. How to find the domain and range? You know that domain of R is the set of all first components 0, 1, 2, 3, 4 and 5. 0, 1, 2, 3, 4 and 5. And the range of R is what? Range of R is what? The set of all second components 0, 6, 7, 8, 9, 10. 0, 6, 7, 8, 9, 10. Right? Next question. If the set A has P elements, and set B has Q elements, then find the number of elements in A cross B. Find the number of elements in A cross B. Now see, cardinality of A cross B is what? This is equals to cardinality of A into cardinality of B. This we know, right? So here the cardinality of A is what? The cardinality of A is P. From here, set A contains P elements, and the cardinality of B is what? Is Q, right? So cardinality of A cross B is PQ. So option C is correct. Next question is this. Question number 5. Let A is equal to this set 1, 2, 3, 5 and set B is the set 4, 6, 9, and let R be a relation from set A to set B defined by R contains all those ordered pair xy such that x minus y is odd. You need to write R in roster form and you need to find the domain range of R and R inverse also. Right? See here. Given is what? Given is set A. Set A contains 1, 2, 3 and 5. Right? And set B contains 4, 6 and 9. We want to find R from A to B such that R contains all those ordered pair so that the first component minus second component is odd. Means difference between two components should be odd. Right? So we will check. This condition we must fulfill that xy will belong to R if x minus y is odd. So check from the arrow diagram over here. Suppose we check the first pair 1, 4. Can this belongs to R? Yes, as 1 minus 4 equals to minus 3, which is odd. Right? See here, x belongs to A as 1 belongs to A and y belongs to B as 4 belongs to B. We take two numbers and their difference is odd. So this pair 1, 4 will belong to R. Similarly, you may check for all these pairs. Right? Take x from set A and y from set B and check whether x minus y is odd. If x minus y is odd, then this pair x comma y will belong to R. See here, x is 1, y is 6, then x minus y is minus 5, which is odd. So we can take the pair 1, 6. Similarly, take x equals to 1, y equals to 9, then x minus y is minus 8, which is even. So we cannot take this pair. Right? Similarly, you may check for the others as well. So finally, what you will get is this R equals to this set. Right? So we need to find the domain range and R inverse. Since we have got this R, then we can easily find R inverse by interchanging the positions. Right? 4, 1, 6, 1, 9, 2, 4, 3, 6, 3, 4, 5 and 6, 5. Now you may find the domain and range of R. You know this very well. So the domain of R will be the set of all first components. Right? So this will be 1, 2, 3 and 5. Right? 1, 2, 3 and 5. Similarly, range of R will be what? The set of all second component 4, 6 and 9. 4, 6 and 9. So that's it for the topic relations. If you liked our content, you may subscribe to our channel and can share it with those who need it. Thank you all.